Yeah, I'm very well, thank you. So hi everyone, GM. You're welcome to the front end session of the Cairo Bootcamp 5. So today you're going to be learning all you need to know about front end, connecting your smart contract to front end. So we have Oshioke Salaki is going to be taking us through the front end session today. So, but before I hand over to him, I'd like to ask how many people have registered for the hackathon? Or maybe I should ask how many of us have not registered? I think that's better. And why? Why haven't you registered? Ebuka, then Daniel. Okay, Ebuka registered today. Daniel, why haven't you registered? The hackathon is starting next week. Yes. Is there a reason why you've not registered yet? Okay, I will share the link. Procrastination, please. That procrastination must die today. Register today. Register today. And if I don't know what your plan is, if you want to ask solo, okay, I'm going to share the link right now. Just one moment. Yeah. So always on the Notion page or the Zoom link. Oh, sorry. Hmm. Register here. Okay. Here's the link. You guys should register. You guys should register and you can start thinking about a project idea already. I don't know if you guys got we're going to resend it, the list of project ideas that you can work with. Sorry, that you can work with. So another thing, your assignments, if you haven't submitted assignment for week 1, week 2, you have grace because the forms are currently still opened. So you have the grace between now and Saturday to submit those assignments. Um it's going to be closed. The form is going to be closed on Saturday. We're going to have assignment for week 3 released tomorrow as well. And I think that's it basically. I'd like to hear from one or two persons how the bootcamp has been. Um, Anybody who wants to share, at least as your learning experience been so far. So if it's something that you like us to adjust or improve on, yes, we'd like to know quickly because we have 2 hours. Anybody, David?
Okay, just to put out my comment, I think the bootcamp has been very great. It's been insightful. If there is anything, or this was what I did, anyways, in preparation for the bootcamp, was that I took a preliminary course on Rust, just to have an understanding of the basic concept, since Rust is quite closely related to Cairo. So I think
Mhm.
maybe that recommendation can be put in when the announcements for other bootcamps are put out. You know what? If you'll be joining this this bootcamp in preparation, you might take some Rust courses so you understand, some of the fundamentals, and then you can hit the ground running. But other than that, I don't think there's any. I don't personally. I don't think there's any other thing that I would want. I know any things can always get better, but I can't really pinpoint, anything that can be improved upon yet. I think it's been very good.
Yeah, okay, awesome. Thank you. Thank you, Daniel. The thing is that you necessarily don't have to know Rust before you learn Cairo, but it's actually really a plus for us developers. It's always like very easy for them to like pick up Cairo. So something that we can add. Thank you very much for that contribution. Is there anybody, any other person that wants to share? Any other person before I hand over to our tutor for today?
Mm. Hi. Okay. Um, I think the bootcamp has been great so far for me. I think I actually joined last year's one, but didn't complete it. So, but this year I'm determined to like make sure I see it through. But I think one thing I struggle with is I do not really. I love to like have all the resources in one place. What I mean by that is like maybe a Google Doc or just a website that has everything I would do every week just in it. Like I don't need to go to Telegram to go and look for the link to the assignment. I don't need to like the link to the hackathon. Everything is just in one document. Maybe Notion, I need just one place and I can get everything
Yes.
I need. Yeah, I would really prefer that compared to like just going to different platforms.
We actually have that. If you check Notion, we have it on Notion. So you
Yeah,
can go to
so
Notion.
yeah, okay. If that is available, I think that would be nice if we only share one platform. Like if any reminder, any stuff, you just say, oh, go to Notion, you will see it there. The assignment for the week is there. The YouTube video link is there. Like anything I need, I'll just find it there.
Yeah, the reason why we do link like every other resources is because some people miss out on details. That's
Mm,
the truth. So, but
okay,
then we're still going to like always have the link to Notion. So if you go straight to Notion, you will find every other thing that you're looking for is there. Is
okay.
there.
Thank you.
Thank you.
Yeah, please help me drop the link to the Notion here so I just
I
save
will,
it.
yeah, thank you very much.
Thank
So
you.
I'm going to be handing over to Showcase. So we have 2 hours. Like we're going to be ending this class 8:30. Sorry, that's supposed to be 8:13, 8:14, no, 8:14 West African time, yes. So please Showcase, you can start. Thank you.
Mhm. Good evening, everyone. My name is. You guys can hear me, right? You guys can hear me well, yeah? Okay, yeah. So my name is Ushuke Salaki, and welcome to today's class. So we're going to be talking about how to integrate your Starknet smart contract into your front end. So let me share my screen so we can start right away. Entire screen, yeah. So you guys can see it, Abby. Okay. So So let's go to how can I hide this? So I'm trying to okay, hide video panel. No, no. Okay, yeah. So yeah, yeah. So let's start right away. So as I said, you guys have been over the past couple of weeks, you guys have been learning how to write Starknet smart contracts. But how can people interact with those smart contracts? You can't send someone a Voyager link to interact with those functions that you've made or make calls to your contract. They need to have an interface for them to be able to interact with those contracts that you've made. So let's say you build something like a voting application. You need a website where people can just easily go. They can see the people that are contesting for election. They can easily cast their vote with a UI and with the appropriate UX. So that's what we're going to be learning how to do today. So yes, I said my name is Ushuke and I'm a blockchain developer. That's my Twitter. I'll send these slides later. So yeah, let's get straight into it. So this is something that you guys already know, the compilation process of a Starknet smart contract. So you know it's all written in Cairo, then compiled to Sierra, then your contract is declared and a class hash is returned. That class hash is then deployed and a contract address is returned. Then one other thing is that after deployment, an ABI is exposed. What is an ABI? So an ABI is basically the blueprints that defines how you interact with the smart contract. It's basically like the DNA of your smart contract. It specifies the contract's functions, what parameters they take, and how to format data for calls. The ABI is basically serve as the DNA of a smart contract. If apparently if you're not new to like web development, you guys must have heard of APIs. So ABI is like the Web3 version of an API. Kind of. So no, um, just ABI is basically the DNA. Made a mistake there. So ABI is the DNA of the contract, and I'm going to show you an example of how the ABI looks. So I have this link here. So if you go to how to get the ABI of your contract, so if you have the contract address, you can just this is going to take time. So when it loads up, I'll let you know. So what is front-end development? Front-end development is basically the process of creating parts of a website or web applications that users can see and interact with. It involves using coding languages like HTML, CSS, and JavaScript to design the layout, appearance, and features that make a website look good and function smoothly. So there are some basic front-end frameworks that we have. And frameworks are basically tools that help developers to build these websites more efficiently and faster. They provide pre-made structures, components, code patterns that make it easier to handle complex tasks like displaying data and so on. For examples of some front-end frameworks that we have in JavaScript specifically are Next.js, Vue.js, Angular, Astro, and Svelte. So for today's class, we're going to be focusing on Next.js. Next.js is a framework on top of React. React is a
Hello?
JavaScript framework. Is there any
Can you hear
question?
me?
Yeah.
How far now? You know he's talking to you. Is this Lizzie? Is this Lizzie?
Um, I don't know.
Yeah, please you can continue and make
Okay.
it.
Okay. So yeah, so we have some front end libraries that assist when we're integrating our smart contract to our front end. So we have Starknet Rust, Starknet Python, and Starknet.js and Starknet React. So when you are using a JavaScript framework to build your dApp, you make use of Starknet.js. But if you're using Python, you make use of Starknet.py. Then for Rust, you use Starknet Rust. So for today's class, we're going to be focusing on Starknet.js and Starknet React. Starknet.js is basically a tool that helps developers to connect their dApps to Starknet. In normal applications, you can remember if you want to connect to an application, is either they tell you to connect with your phone number, your Gmail, Twitter, and so on. Those serve as your identity in any application. But for Web3 applications, you connect with your Starknet wallet, as you know, Ready or Agent or Bravos. So it helps with easy interaction with smart contracts, such as sending transactions and getting information from the blockchain, and like checking transaction status and reading contract data. Then Starknet React is also a library that provides those same tools and hooks to interact with Starknet, making it simple for users to connect their wallets and fetch blockchain data directly from React components. So yeah. So for this coding session, these are the these are the these are the tools that we're going to be using, which was provided to you guys. So your code editor, VS Code, you have to have Node.js installed and set up in your computer. Then you need to have an Alchemy or Infura account, but I feel like Alchemy is easier to set. That's one I personally use. Then the contract address that we're going to be integrating. So we have this contract address here, then the contract ABI and starter code, which I also provided the repo for you guys. So yeah, so we don't need to do too much talk. We need to get into coding straight away. So so yeah, so I provided the starter code for you guys. Um okay. So it was on GitHub like this. So you have to clone this. So you clone the repo. So I have it cloned here already. and you can see a starter subdirectory here. So you need to cd into starter like this. Let me expand my screen so you guys can see it well. Please, if there's any question along the way, feel free to unmute your mic and talk. So we have our, I don't know, my screen is big enough, Abi. It's zoomed in enough. Okay. So yeah, in this starter directory here, we have a list of files and folders. We're going to go through each of it one by one. So for most people, this is their first time coming into React or Next.js. So it might be a bit difficult, but I'm going to try and break it down as simple as possible. Then also, if you want to, maybe after this class, you want to go into like front-end development, maybe you want to learn a bit about it, I can recommend some courses from Udemy you can check out. You can check out this course by Jonas Schmedman. He has a JavaScript course and a React and Next.js course. So you guys can check that out if you want to go into it. So yeah, so we have some basic boiler code. I'm not going to bore you with the information, but this is just a configuration file that is used for TypeScript. You're going to make use of TypeScript instead of JavaScript. TypeScript, you know how in Cairo you define the types of your variable. That's the way TypeScript is. So instead of just calling variables, you need to specify the type of each variable. So this is the configuration file. We have a README. I'm sure everybody knows what a README is. This is also a post CSS configuration file. Package.json, you know how you have scarp.toml where you list out all your dependencies for your contract. This is what this file also does. So you list all the dependencies that you want to use for this application. Package.log.json is a generated file. So when you run your application, this file is automatically generated. So you don't touch anything here. Then this is the next config file. This is where configuration of Next.js is done. Then this ESLint.config. ESLint is a linter that helps to format code. So this is where your configuration lives. You don't need to touch this. Then public folder. This is the folder that you usually keep icons or images or fonts inside. So if you have anything like that, you can put it here. Then we have a lib folder here that I created. So this lib folder, I just basically have, okay, Obi has a question.
Okay. Good evening, sir. Sorry for the interruption, but all these
It's okay
codes
now.
now that were specified, how were
Okay.
you able to um was it you that write it or is generated? How do
Okay.
you able to get the code?
Okay. So let me show you guys something. So as I said, I already did some boilerplate code so that we don't waste time. So we can just jump into like the integration straight. So this is the Next.js website. So this is the framework I'm using. And for you to start building your Next.js app, you just need to run this script here, npx create next app at latest. So it gives you the boilerplate code. Then you can now build on top of it. But we're not trying to like do an intro into front-end development. So that's why we have some boilerplate code. So I also listed some courses that you can go into that will break down how to get started with Next.js and React. But this particular code is in the repo that I've attached. So you can get this starter code from there. So yeah, so I have this
Oh,
lib folder here. I don't know if that's clear, John.
yes, sir. Thank you very much.
Uh, so in this coin.ts, where I have some variables here. So this holds like the contract addresses for Stack, USDC, and ETH. Then I have a utils folder here that just holds the contract address and some utilities. So if you, after cloning your repo, you notice that some values are appearing in red here. So, and that is because we've not installed our dependencies. You know, I mentioned our dependencies in package.json. So we need to install those dependencies. And to install it, you just need to run npm I like this. Mm, So this is So this is what we use to install our dependencies. So depending on your network, this might take a bit of time. So I'm going to be talking about the other files. Then we have this context folder here. So context is basically worldwide states. So I don't want to go into details. Well, I did a mock. We're going to eventually delete this folder. I just did a mock presentation to show how our wallet connects, but we're going to delete it later. Then we have a components folder. So the way Next.js works is that it allows you to build components. So every application is made up of several components. Components are basically the building block of every application. So let me give you an example. This GitHub website now can be a whole app. We can use we can call this navbar a component. So this navbar is on top of this main page. So we can have a main page component here. Then in this side, we have our about here. This can be an about component and so on. So it's basically, you know how you build a house. So you put maybe you put the sand, then you put this, then you put that. So that's what, so you break your app into several components like Lego. Lego is like the perfect example. So you know you have different Lego pieces. So yeah. So we have our components folder here. So we have some components that are built out already. So yeah, we'll just look at that later. Then our app folder. This is this is the main folder. So in this app folder, we have our page.tsx folder. So this is the folder in which, so this is our main app. This is when we run our server, this is where the server goes to first to render. Then we have our layouts. So this is basically how the app is, the layout of the app. Then globals.css, this is where we put our styles. Then we have this ABI folder. ABI folder is where we are going to be putting our ABI, as I've mentioned before. So now our dependencies have been installed. So the next thing that we need to do is that we need to run our application to see how the application currently looks. So you just need to run npm run dev like this. This is how you run the server.
Everybody.
So our server is currently running and is running at localhost 3001. So if you go back, so we just need to copy this part, then go to your browser, then open that server up. So this is how our app looks. So I'm going to be building something very simple so that it doesn't look as tedious. So we're building a simple counter. So yeah, so we have our navbar, the header, then we have our accounts here. So currently our accounts works well, but it's not linked to our contracts in any way. So the basic functionalities of this app is basically just to increase our accounts, reduce the counts, and refresh the counts. So that's what we are doing. Then you remember when I talked about how you connect to an application? So we have a connect wallet. So to connect our wallet, you choose either Bravos or Ready. So this is a mock demonstration. So if I click on Bravos, it spins up, and we now have this. So this is just a mock whatever. So it's not actually doing anything. So we're going to integrate it fully in this session. So there we also have a disconnect. So that's how it works. So the first thing that we're going to be doing is how to get our ABI. So in the utils folder, I already gave you guys the contract address. So you just need to copy this contract address and go to Voyager. You go to Voyager online. You make sure that this is set at Sepolia because the contract was deployed on Sepolia. Make sure it's set as Sepolia. And when it's set as Sepolia, you just need to search that contract address here. And you see the contract here. Okay. Then, so if you scroll down, you can see things like events, messages, code, class history, read contract. So you just need to go to this code section here. If you scroll down, you see the contract ABI. So let's copy this and we're going to look at it in details. So after you copy the ABI here, you just need to come back to this ABI folder, counter ABI.ts, and replace this empty array with the ABI like this. So let's look at this ABI. So the first in the ABI, we have our implementation. So this is the implementation from your contract. Then we have the interface. So this interface is basically lists out all the functions that you have in this contract. So in this contract currently, this is the first function we have. You see type function, name, increase counts. The inputs, it takes in an array of inputs. So, and it only has one input, which is amount. So you increase the amount, the account by, you can either increase it by 1, by 2, by 10, by 1 million, etc. Then it shows the state mutability and the outputs. So it doesn't output anything. We also have another function, increase count by 1. So this function does not have any inputs. So it just increases the count by 1. So we have decrease count and decrease count by 1. We also have the last function, which is get count. So this is the function we use to retrieve the count stored in states, and it returns a felt 252. Then we have an event. So this is supposed to hold the events of the contract, but we don't have any events in the contract. So that's why the events array is empty. So this is how the ABI looks. As I've mentioned, this is the DNA of the smart contract. So the next thing that we need to do is to get our RPC URL. Our RPC URL is basically like your API key. Let's say like your API key that helps you to make calls to the to the to the smart contracts or to Starknet network. So I told you guys were told to open an Alchemy account. So Alchemy is an RPC provider. We also have providers like Blast API or Infura. I'm sure you guys used I'm sure you guys use an RPC when you were learning how to deploy a smart contract on Starknet. So yeah, so it's basically the same way. So you set up an Alchemy account if you don't have one. So you can create a new app, or you can use an existing app that you have. You now go to the endpoints to get the Starknet Sepolia endpoint URL. So I just need to, so if I scroll down, Starknet Sepolia here, then so V10. So this is the link. So what I just need to do is to create an env file. So you create an env file. So this is where your environment variables. So this is for environment variables. So so this is basically a place where you can keep secret API keys that you don't want exposed when you push to GitHub or you deploy your application. So it's going to be called so you usually use capital letters. So next public RPC. So if you're not following along, don't worry, I created like a list of the steps that we need in a hackmd file. So you guys can go through that later to see what we are doing so you don't get lost. So we have our env file here, and this is where, so we've placed our Starknet Sepolia Alchemy RPC URL here. The next thing that we need to do is that, remember how we talked about those libraries that we need when interacting with our smart contract? We need to, so Starknet.js and Starknet React. So we need to install those dependencies in our application. And in order to install those dependencies, we just need to run npm i. Okay. So you do npm install. So the first dependency we are going to be installing is Starknet React, like this, /chains. Then the next thing is Starknet React /core. This is Starknet React slash core, then Starknet, all in small letters. So this is my true and error of peer dependency. So you just need to append that with dash dash legacy dash peer slash depths. I don't know, does anybody have any questions so far? Like you guys can ask anything on while this is installing. So if there's no more question, we can move on. So we've successfully installed our dependencies, and in order for you to confirm that these dependencies have been installed, so you go to package.json like this. So you can see that so see Starknet React chains, Starknet core, and Starknet here installed. So the next thing we need to do is that we need to set up a provider. Let me just open this hackmd file so you guys can, so it's just so you can see how it goes step by step. So we need to set up a provider. So what is a provider? A provider is basically like, the simplest example is I can think of is, let's say you want to install Starlink in your house. You can't access Starlink in your house if you don't have it set up, right? So think of a provider like something that is wrapped around something in order to provide a resource. You understand? So if you wrap your Starlink, if you set up Starlink, Starlink is like wrapped around your house at that moment. And anybody within your house at the time can access the internet through the router or the antenna that is set up. That's basically what the provider does. It enables you to wrap your application it enables you to wrap your application in order to be able to interact with the Starknet network and your smart contracts from your app. That is what the provider does, and we need to set that up. So I have this code already, so that I will not waste time. So I'm just going to copy it, and we're just going to create a new component. So in our components, we're going to create a new file. I'm going to call it providers dot tsx. So this is a component that we are creating here like this. And components always return something called JSX. JSX is a combination of HTML and JavaScript together. So I would have loved to go in depth, like really break down some things, but because of our time and what we are mainly focused on, we have to skip a lot of stuff. So yeah, so we set up a provider's function, a component. So providers are basically functions that return something. So this is how you set up a function normally. So you have a function with some arguments, children. So in the function, we set up our connectors. Connectors are basically wallets that we can connect to. So in this case, we can either connect to Bravos or Ready. So we set up our connectors using injected connectors. Injected connectors is the method that is gotten from Starknet React. So we use the recommended, we see Ready and Bravos. There's also an attribute include recommended, only if there are no connectors, order is alphabetical. So yeah, then we return our Starknet config. So Starknet config takes in some arguments. So we're going to take in paymaster provider. So I'm going to talk about this much later. This is the paymaster provider, then the chains. So we're currently going to be working on Sepolia only. So you need to just pass in Sepolia. If we're working on mainnet, you just write, so you just import mainnet from Starknet React here, like this, So, but we're only dealing with Sepolia. So we don't need mainnets. Then we have our provider. So this is where we are calling that RPC URL that we've imported to our app. So you see JSON RPC provider, the node URL is process.env next public RPC URL. So remember from our env, that's what we have here. So that's what we are going to be calling here. Then the connectors that we're going to be using, that's what we have here. That's Ready and Bravos. Then the Explorer that we're going to be using is Voyager. So this is how the providers of, this is how you set up a provider in your application. So I don't know if there's any questions so far. So the next thing that we need to do is that, next thing we need to do is that we need to wrap our app in a provider, because currently this provider stands alone. So we need to wrap it around our app. And the way you wrap it is that you go to layout.tsx like this. And we already have this provider here. This is the dummy provider that we have that enables us to do all those mock stuff that we were doing earlier. So we need to take this out. So we'll take that out and we'll use the new provider that we've created. So providers, so make sure that it's this one where we have it in components and the name is providers. So then we are now going to put our children here. Children basically represents the entire app. So that's what children means. So if we go back, if we start up our server again, we'll notice that we'll notice that all those stuff that we're doing before doesn't work anymore. So localhost 3001. Okay. Okay. So we have this error here. In case you come across the error when you are setting up your work, what all you need to do is that we don't even need these headers. We can just remove it. You just remove it and that should work. Okay. So you can see that we're currently using the other provider in the rest of the app. So we can just skip this error for now. So let's just go back to our steps that we are following. The next thing that we need to instantiate a provider in utils. So apart from that provider that we've created, we need to have a provider variable that we can use. I'll show you how we are going to use it later. So in utils, you just need to call this like this, RPC. So you import RPC provider from Starknet. So my provider, new RPC provider, the node URL is what we have in the env file. The next thing we need to do is that we need to connect wallets. So that's the next thing that we need to implement. I think I should. Let me just clear this up. Let me delete. So you guys can go ahead and delete this context folder because you are not needing it again. Then so I'm going to open. So anywhere that context is being used, so you can just comment that out, and you can just so you can see how our app currently looks. Now I'm going to push this final code soon also. So we delete this former provider. I think we should. It's also in connect modal. So we're supposed to do the connect functionality now. So let's just handle that right now. So for connection, we go to the connect modal like this. Then we remove this use wallets, whatever. So Starknet React. So let's go to the Starknet React documentation. So it's Starknet React. So Starknet React basically shows you the dependencies that you need to install that we've done previously. Then this is how we set up the provider as we've already done. So this will give you like more information on on everything about the provider. Then the next thing, wrap your app in the provider as we've done. Then Next thing now, we need to know how to use the hooks. So if you click this, you go to we have use connect. So this use connect hook is a hook provided by Starknet React that enables you to connect your wallet to your dApp. And it's very easy to use. It's as easy as just doing use connect like this. And use connect returns an object. And this object can be destructured. You guys know about destructuring. And connect is available in the object that it returns. So we destructure that out, connect here like this. Then the another thing that it returns connectors. So connectors is basically a list, an array of the available connectors that we have, which is Bravos and Ready, as we've defined in our provider. So we have this handle connect here, like this. We have handle connect and okay. So the first thing that we need to do is we need to display the correct wallet. So if you go to the main body like this, you see that we have two buttons here. So these two buttons are Ready and Bravos that we manually impute the details. But we want to fetch those wallets from the connectors variable that we got from use connect. So what we just need to do is that we need to open this curly brace. Then we map through the connectors available. So connectors.map like this. So um so so the individual one is called the connector. So for each connector, we want to return this button like this. So yeah. So instead of manually putting the wallet name, we can just do connector dot name like this. Then we have the image. We have connector dot connector dot icon like this. So I know this whole thing might look weird. So we'll do this as string. This is basically typecasting, like doing try into or try or into in Cairo. So this is how we typecast. So we can now remove this part. So when any of the connectors is clicked, we need to just pass in, I think for this handle connect, instead of passing the wallet, we pass in a connector. And the type of this connector is connector. And the type, we're importing the type from Starknet React like this. So whenever we call handle connect, we just need to pass the connector like this. So this connector is an object. Then yeah, set connecting. Okay. So for connect, we just need to pass in for when we call this connect from this connect, we pass in an object and the object takes connector. So connector. But in the latest version of React, of JavaScript, when you have the value and the name as the same thing, you don't need to call it twice. You can just do it like this. Same thing in Cairo. So yeah. So this is how we handle our connect wallet in. I don't think there's need for this. Okay. Yeah. You guys have a question?
I can hear you.
Jaffa, do you have a question?
No, I don't. I don't have a question. Sorry.
Okay, okay. So the next, so let's confirm that our connect works. But I need to do something. Okay, this, so let's go to our nav bar. So in our nav bar, we're still using this use wallet. Um, so you so use wallet currently is we are making use of these variables from use wallet. Is connected and address, and we need those two variables. So is connected is basically a Boolean value that says yes, a user is connected, or no, a user is not connected. An address is basically the address of the user that is currently connected to the dApp. So instead of getting it from use wallet, we can also get those variables from use account, which is another hook from Starknet React. And it also returns an object. And this object contains is connected, an address, and even accounts. But for now, we just need the address like this. So we can remove this part here. Then I think, yeah. So our app is working now. So let's test out the connect that we've done. So when we click on connect, oh, so we have an issue. Our wallets are not popping up. So I think I've had this issue before. So the issue usually comes from this part. Yeah. So you might have an issue where when you click on connect wallet, the wallets are not popping up. So it comes from this part. I think there are two options. So only if no connectors and always. So instead of only if no connectors, you can just set this to always like this. So yeah, so it always shows the connectors. So you can see we have our two wallets available, Ready and Bravos. So yeah, so let's connect to Bravos. Yes. Okay. So yeah, so I currently have some Sepolia stack available. So if you guys need Sepolia stack, you guys can check out the faucets, the Starknet faucet. So yeah, so I have that available right now. So let's try. So you can see that our wallet has connected. So you can see that my address currently appears here, E719, and that is what is here, E719. So you remember how we got the address in navbar? We got the address here, and we are displaying that same address right here. And that is what is being displayed here. So this is how connecting our wallet works. Then the next thing that we need to do is that you can see that this value. So this value basically is supposed to show you how many stack tokens that you have. And you can see that my wallet here, I only have 157.8 stack tokens, but here it is showing 1,000. So we need to fetch that correct data. So to do that, basically what we just need to do is, so we have a component called token balance here, like this, and that balance is hard coded here as, okay, it's like a fake timer here. So in order to fetch the balance of our wallet, we have something called use balance from Starknet React. So use balance takes in an object. So we define the first thing it takes is the token. And remember, we already set the token, already have the token addresses. So we use stack sepolia. Then the address of the person that we want to fetch the balance of. So for address, we're going to get address from user accounts. Address is equal to, I'm going to show you two ways of actually doing this, or no, I'll just use as assignments or something. Yeah, assignment is better. So use account, sorry. So use accounts, we get the address from there. Then the next thing that it takes like a refresh interval. So at what intervals is the balance going to refresh? So let's do about 5 seconds. Then the next thing that we can pass in is we can pass watch. So this constantly checks for updates. So watch. So this use balance hook returns an object. So it returns I can't remember now, so we can check here. So we have use balance. So what does use balance return? It returns data or error. So for each hook in Starknet React, you can actually read about the hook. You can see what it returns and how it returns it, and the arguments that you need to pass and what they do. So it returns data and error. So let's use data like this. So this is the data. Then we can pass data here, data dot formatted. So this formats the data. But I'm curious, let's see how the data actually looks. It also returns is loading. So this is basically true or false. So we can have like a loading state when it's loading. So so instead of this loading here, we can rename it as loading and cancel this. Then I don't think we don't need this. Also, this is connected, it's hard coded. We don't need that. So we just get that from user accounts. Then I think that should work. So I want us to see how this data looks. So we use something called a use effect. So use effect basically says, use effect basically says, do this. Do this when this happens. That's how simple I can make it. So we're going to basically, what we're going to do is that we're going to console.log is like print line. We're going to console.log the data anytime data changes. So this is a dependency array. So this array basically says that we run this function anytime anything in this array changes. So data, we're going to say this raw balance data like this. So if we go back here and we open our console, so you see so it returns this object here like this. So you see the decimals, the formatted version. So the formatted is 157.84. The symbol is stack, the value, and all. So it's the formatted that we are passing. So I don't even know, it's not even displaying, which is dot to fixed. Next parse. We're going to call parse float because the formatted comes as a string, so we need it as a floating integer. So this is type coercion, as I've mentioned before. Type string. Dot to fixed. So this is basically to make it 2 decimal places. So this usually gives an error, and I don't really know why. It doesn't display the value here. I've still not been able to figure that out. But later in the course, I'm going to show you another way to fetch the balance that it shows. So we can just move on. We can just move on from that. So now we've seen how to fetch using use balance, even though it's not working, but we're going to use another method later. So the next thing that we need to do, my time is going so fast, we need to handle our disconnect wallet. So I currently commented this out. So we have a disconnect modal here. So we're going to remove the wallet context that we had before. So we're currently making use of address, disconnect, and wallet name. So to get address, as we've learned before, we just need to call use accounts. Use account like this. So we just call address. Then in order to get disconnect, we have another hook from Starknet React called use disconnect. So use disconnect like this. So const and use disconnect returns a disconnect function that we can call. So as for this wallet name, there's no need for that. We can just change this to connected. So the wallet name was basically to fetch whether we are connected with Bravos already, but you can get that information from when you import accounts. So yeah, in order not to waste our time. So yeah, so when we click on this disconnect button, we call handle disconnect, and handle disconnect basically just disconnects then closes the modal. But it's very very simple. So these hooks really abstract a lot from us, so it makes it easier for when we are doing integrations. So yeah, so we connect our wallets with Bravos. I don't know. It currently shows that our okay usually works. Okay. Okay. So yeah, so after we connect our wallet, if we click on this, it pops up our modal where we can copy our address. Then we have disconnect. So this disconnects the wallet. So our wallet is no longer connected. So far we've learned how to connect our wallets and disconnect our wallets. So I don't know if there's any questions so far before we get into the main stuff. Do you guys have any questions? So I assume there's no questions about this. That you guys are senior developers. So yeah, the next thing that we're going to be going into is we're going to be so we've done connect, disconnect, use balance. Then now next we are going to we have fetched our ABI already. The next thing we are going into is use read contracts. So we are going to be making use of use read contract as a hook also from Starknet React. So where are we making use of that use read contract? So if you go to page.tsx, where the count is being displayed. So this is where count is currently being displayed in line 49. So we just go to the top of our screen. Then we call use read contract like this. Use read contract. Then this takes in an object. So in the object, it takes in the ABI, number one, and that ABI is what we defined here as counter ABI. So we type in counter ABI like this. Then after ABI, it takes in the function name. Function name, and the name of our function is getCount, if I'm not mistaken. Let me open up the ABI to confirm. Yeah, get underscore counts. So you have to make sure it's really type. You have to it's case sensitive. Okay. So we're having a type error. So we need to do our typecasting. So we just import the ABI type from Starknet, and that goes away. Then apart from the ABI, we have the contract address, the argument, and refresh interval. So we have address, which is we have it as counter contract address. Then we have the arguments. The arguments for get count, there's no inputs for get count, so it's an empty array. And then after arguments, we have a refresh interval. So refresh interval, we're going to set it at let's say 10 seconds. So 10,000 like this. So what does read contract return? So read contract returns it returns data, refetch is error, is loading, or error. So you might not need everything. So let's just do data and it's loading like this. Data is loading and refetch. Refetch is a function that you call when you want to refetch the data. So refetch, and we also have is fetching like this. So it's fetching and is loading our loading states. So yeah. So we just need to call instead of using counts here. So we can just remove this actually. No. So our app won't break. So instead of using counts, we just let's remove this. Or we can just remove this part and just put an underscore here. So instead of data, we can rename this to counts like this. Rename this to counts. So if you go back to our app, you see that our count is currently at 94. And to make sure that we're not like fabricating a number from somewhere, if you go back to Voyager, you can go to read contract here and you can call this get count here. And if you query it, that should also return 94. This one is kind of bad still. Um, um, we're having Voyager has been acting weird. So yeah, but I guess you guys just have to take Starknet React word for it. So you take their word for it that the count is actually 94 and not something else. So this is how we read from the contract using Starknet React like this. At the same time, we can also make use of Starknet.js to read from the contract instead of Starknet React. I'm coming. So just give me a second. Okay, yeah. So for Starknet.js, all we just need to do is I already have this boilerplate code here. So instead of using a hook, you can just create a function here like this. So this function, we're calling it we're going to be calling this function read contract with Starknet.js. Read contract with Starknet.js, and is going to take in a function name, arguments, and so on. We don't even need to do it as a okay. We don't even need to do it as a function. Okay, let me just clear this up. So we just need to have, so the first thing that we do, we need to instantiate a contract class like this. So it's basically new contract. So contract is from Starknet. We pass in the ABI, counter ABI, then the contract address, counter contract address, then the provider that we've called before. So we just do my provider like this. So okay. So I think we're having an error. Expected one argument, but got three. Okay, we're supposed to have. So it's supposed to be an object. So ABI like this, address like this, provider or account like this. I think, yeah. Then after that, we await, no, we just, so we call that contract with the function name. So get counts like this. Then the arguments, there are no arguments for this contract. So we just return the results. I think we need, okay. No. So yeah. So let's see if this result returns the same thing. Results. If it doesn't, that means we need so we actually need to make it in an async function. So async function get JS. Let's say get JS count like this. We just pass in. So we await here like this. Await return to return results like this. So we just call the function here, get JS count like this. So this should work now. We don't need a wait here. These as a use effects. So so we call get JS counts. Const data is equal to this. So we can just see set counts as data like this. I just call it set data res. I think we just need to just make this as any. Okay. So yeah. So we can call this we can call this data here. Sorry, I'm trying to set this up. Okay. So if you go back to our app, this should work now. So yeah, so Starknet.js also works. So basically, let me just run you guys through it. So, uh, so for Starknet.js, basically, we usually do it. You can do it in a use effect like this. You can define an asynchronous function. Then the first thing you do is you instantiate your contract. Then you call the function directly from the contract like this. Then you return the results. So in that result, you can now set it to a state variable. So that's basically what we did. So you can either use Starknet.js or Starknet React to fetch data from the blockchain. So I'm going to remove all of this because and we just stick to our normal to the counts that we've used. That we use counts like this. So you see that both of them gave us 94. So yeah, the next thing that we need to do, so no waste time, is so the next thing that we need to do is we need to learn how to send transactions. So that is how to write to the contract. And we're going to be using use send transaction from Starknet React. So that's for the increase button and decrease button. So let's start with increase. So use send transaction like this. So let's go to Starknet React to see how it looks. So use send transaction. So it takes in, first of all, an object like this. Then we have calls. Calls is the first attributes. And calls is basically an array. So you can just copy this here, like how they have it here like this, and just paste it. So it's going to check if we have a contract and an address, that's when it should return a call array. So we need to set up this contract. So const contract. We have a hook also from Starknet React called use contract like this. Starknet use contract, and use contract accepts an object. It takes in the ABI, which is counter ABI, and also the address of that contract. So address is counter contract address like this. So we need to do that typecasting here again. So as ABI. So then we need to get address. So const address is equal to use accounts like this. Yeah. So when we have a contract and address, we now pass in this array. So we do contract.populate, then the name of the function that we want to call. And the name of that function we are calling, according to our ABI, is increase count by 1, like this. So increase counts by 1. And it doesn't have any arguments. So this is where you pass in the arguments. So since there are no arguments, you just pass in an empty array. But if there is no contract or address, the call is going to be undefined. So that's what it takes. So what does it return? So it also returns an object that we can destructure here like this. So we have send and we have error like this. Send and error. So send is the asynchronous function that is being returned to us that we can use to call. So like the same way we have connect and disconnect. So we can call this handle increase. Or no. Let's just call this increase. increase like this. Then we have error. So that's basically it. So we already have a handle increase function here. So instead of calling set counts, we change this to increase like this. So this calls that function in the contract. So yeah, so let's try it out. Remember that we're calling a write function. And when we are making changes to the contract, then there has to be a signer. So your signer is basically the wallet that is authorizing, that is making that transaction. So we need to sign it in our wallet in order for it to work. So if we click plus here, no, it doesn't work because our wallet is not connected. You remember that check that we had? If there is no address, it doesn't work. So we connect our Bravos like this. Then if we click on plus, our wallet pops up like this. So you see the transaction. We are calling increase counts by 1. This is the contract address. For the call data, we don't have any arguments. So that's why it's also empty here like this. So we see the network fee, then we just click on sign like this. So yeah, you can see that our state has already updated here. So our count is currently at 95. We haven't made this to work, this refresh. So let's go back to our page. So in that, so we have this rotate. So whenever this button is clicked, we basically just want, what do we want? We want to call refetch as we've defined up here. Or we can just rename it to call refetch counts like this. We refresh the counts. So we call it here refetch counts. I think we need to make it event handler like this, refetch counts. So yeah, so if we refetch, I think how will we make it to know if it's loading? So there's no loading states. So that's also going to be an assignment for you guys. So anytime we click this, it actually refetches. So let me prove that here. So if it is fetching, we want to see loading like this. So if you click on this, you see that we're showing loading. So that proves that the refetch is working. So we'll cancel that. So yeah. So we've learned how to, so that's how you can handle increase. So handle decrease is basically the same thing. We just need to copy and paste this same code like this. So instead of calling send here, we just call decrease. Then we change the function name here to decrease by 1. Then errors can be error increase. Then we can have error decrease like this. I hope there are no questions. If you guys have any questions, you guys can say so. So yeah, so decrease. So we just need to, instead of having set counts here, we just call decrease like this. So remove handle refresh. So yeah, so let's try out our decrease. So if we click minus here, our wallet is not connected. So we connect like this. So if we click minus, you see that we're calling decrease counter, then we sign the transaction. So yeah, so our state did not update on its own. So if you refresh it, you see that our state is back at 94. So let's reduce it again. Let's see. Sign this transaction. So yeah, 93. So that is how we can read and write to the to our contracts. So is there any questions so far on everything that we've done? I think James, do you have a question? Mm, okay. So since nobody's asking any question, Obi, are you clear on everything we've done so far? I'm going to be calling everybody's name. Obi?
Yeah, I'm quite clear for now. I think I'm getting it. Although I need more like personal practice to understand it. But yeah, I'm
Yeah.
following.
Okay. Hakeem, what about you?
Yeah, it's clear, but
Okay.
I'll have to like go back to it and check it properly.
All right. David Tolulope. David Tolulope, how's it going? What about you, Martins? Okay. Um, did someone say no? Collins, are you the one that say no? Collins. Okay, okay. So yeah, so let's look at the next thing that we need to. So this the same way you can also use Starknet.js to write to your contract. So the last thing that we're going to be looking at today is the Avenue Paymaster. So Avenue Paymaster. So the major problem with creating dApps in the space is that when you are trying to onboard new users, people that maybe are new to Web3, I don't know if you guys have interacted with some apps that you need gas fee before you can interact with them. And it can be quite frustrating because people might imagine looking for a gas fee of about $0.01. Then you have to like go and buy, and you know how is a minimum buy. Maybe you need to buy about $2, $5, and so on. So Avenue has provided a paymaster that allows you to sponsor your your users gas fee, and they have two options: either you go gas free or gasless. So the gasless option is basically allows you to choose a token that your users can choose any token that they want to pay gas. So you can, instead of using Stack, they can make use of USDC, ETH, or USDT to pay for their gas. But for gas free, there's no gas at all. The gas is being sponsored by you, the developer, in which is sponsored by Avenue actually. So Avenue gives out API keys to developers, so you can join their developer community on Telegram. They give you an API key, and that API key allows your users to like make use of your app gas free. So, but if you're having heavy coverage on your app, if you're having a lot of users, you might need to top up from them. So it's like limited. So I'm going to show you guys how to integrate um gas free. But before that, remember I told you that to fetch our token balance, we had another way of doing that. You know that Stack is basically an ERC20 contract, right? And because it's an ERC20 contract, that contract has been deployed. And since it has been deployed, it also has an ABI. And that ABI can be interacted with. And that means we can use that ABI to call read and write functions using Starknet React. And we all know that every ERC20 contract has a balance of function. So you can basically call that function here in this token balance component and get the data and display it here. So that is going to be part of the assignments for you to do. So use Starknet React or Starknet.js to display the balance of stack or whatever you want to display on the app. So that is how that is the other way. So let's go back to Avenue. So you have the Avenue docs here, the Avenue Paymaster docs. So so this is documentation about everything. So this is where you can get the API key. So you fill up a form and the API key is sent to you. So okay. So yeah, so let's set up the gasless option first. So I'm going to take your attention back to our providers components that we created. You notice that part of the props of this Starknet config is a paymaster provider. So this paymaster provider basically allows you to set up Avenue Paymaster that you can use in your app. So here we set up our RPC here with the node URL. So because we are developing on Sepolia, that's why I set that Sepolia Paymaster. Then we have the headers. In case you have an API key, you can use that API key here, like this. So in order to yeah, so to use this gasless, we just need to call so yeah, this is what we need to do. So let's use it for increasing our balance, increasing our accounts. So like this. So we need to instantiate a paymaster variable. So we just call our paymaster RPC from Starknet with our URL. Then we need to we need to do we need to do this. So we need to set up a used effect again here. Right? No, we don't need that. So we just do async function. Um, increase, we call it increase paymaster like this. Then increase paymaster accounts. We're supposed to get accounts from user accounts. So we just call accounts here. So accounts does execute. Okay. So if there is no accounts, we want to return. So account to execute the call. The call that I want to make is for increase. So we just copy this like this. Um, you can just pass the array directly. So if there is no count or if there is no contracts or if there is no or if there's no so yeah or if there is no contract, we should return. So this is the call that I want to make. Then paymaster time. They have an error. We're supposed to say executes paymaster transaction like this. And paymaster. Paymaster detail. I'm coming. Okay. We just need to pass this in to the fee mode. Okay, we're going to create a variable here, and we're going to call it fee details.
And I already get it now. She don't tell me what to do. She just look, they look.
So we call this fee details, and so the mode we are going to be going for is we're going to be going for the default, then the token, right? Gas token, sorry. The gas token we're going to be using, let's say we want to use USDC Sepolia to pay for the gas fee. So after the calls, we then pass in the fee details like this. Yeah. So okay, then we have a fee estimation. So passing fee estimation, then the call that we're making like this, and yeah. Okay. So sync. So return results like this. So for handle increase, we're going to make this an async function. Then we're going to await increase paymaster like this. So we still have handle increase. So let's see how this works. So if we click on plus, it's not working. We're having an error. Okay. So, okay, our wallet's not connected. Okay. Failed to fetch. Page 188. I think this is so our fee details, okay. So the fee estimation, sorry. Right? No. I also use fee estimation. Okay, yeah. So after fee details, we need to pass in fee estimation like this. Okay. Then I think that should work now. It's still saying name not resolved. Failed to fetch 88. So I think the problem is finding it hard to get the estimates, the fee estimates that we need for this transaction. So I'm not really sure why that is even why it's even an issue. Oh, I think it's because of the way we are I think it's because of the way we are making our calls. Resistant type call. So let's try this. Increase counts by 1. Call data empty like this. Okay. So let's try it again. It's still not working, and I'm not sure. I think it's a problem with our versioning, but I am going to check it out and let you guys, let's see, and we increase like this. I think the problem is maybe from Avenue. So I'm going to do like more research and see what the issue is. But that is basically how you can integrate Avenue. So with this allows your users to pay for their gas fee in USDC. You can also change this to the ETH Sepolia address or USDT Sepolia address, and that's how it works. But if you want it to be sponsored with your API key, instead of default, you change this here to sponsored like this. And your gas fees will be sponsored by Avenue. So they don't need to pay gas fee, they just need to sign the transaction, and that's all. So that's how it works. I don't know if you guys are still hearing me. So yeah, and that's the last thing on our list today. So I don't know if there's any other questions on, or if there's anything that you guys want me to reiterate before the time goes out or explain. So does anybody have any question or anything they like to contribute or say? Okay, so if there's no question, that brings us to the end of today's class. So today we've been able to connect our wallets, disconnect, set up our providers, read from the contract, and write to our contracts. And yeah, so and we've been able to talk about Avenue
Hello.
and Avenue
Hold on, sir.
Paymaster. Okay.
Yeah, please, I have a question. We are saying that we can sponsor the gas fee of our users, and you
Mm,
said from Anno we are going to be giving an API key, but I don't see where we can fuse it like something like API key. Then we now put
okay.
it then.
Oh, I mentioned that. So in your providers, you notice that we have a Paymaster provider here as a prop. So in the headers, there's this API key. So you can save the API key in your env file and call it here.
Oh,
So that's how
thank
it
you, sir.
works.
Thank you, sir.
Yeah. So does anybody have any other question? If there's no question, then Sarah, over to you.
Yeah, thank you very much, Moshioki, for that very insightful session. So, guys, you must have question. No? We still have some more time left. You guys should think about questions to ask, please. Think about questions to ask. For people who are just joining the call, or people who join the call later, is there anybody that have not? Okay, yes, please, Obi, go ahead.
I'm sorry, sir. This is not a question, but can you like go back to your .env file? Just
You
want
want
to
to
see
copy
the
my
name.
RPC URL?
No, no, I just want to see like the name you used to save
Okay,
it.
okay,
Okay, you
sure.
save it as next. Okay,
I
Yeah,
don't
don't
know
okay,
worry.
whether
okay.
it's
So,
your network, but hello?
so the reason why is next is that so when you're naming env variable file, env variables, you need to prefix it with next public. So this allows it to be available on the client side. That's the front end. So that's why you always need to prefix it with next public.
So, sir, this RPC now, is it the API key you're talking about?
No. This RPC basically allows us to interact, to make calls to our to the smart contracts.
Okay, thank you, sir.
Okay.
Any other question, guys? Any other? So as I was saying, for people that
Hi,
join
Sheke.
later, okay, please go ahead.
Okay.
All right, sorry. So I have this question, more on the paymaster side. I think for ERC20,
Mm,
um,
mm,
or let me put it this way, since it's possible for Avnum or to sponsor gas fees using Avnum Paymaster, is
mm.
there a scenario where transactions are rejected or the paymaster um, rejects a transaction or tries not to sponsor a transaction maybe because the max allowable that fee isn't declared or are there scenarios where paymaster just wouldn't want to sponsor gas fees?
I don't think the only scenario is when maybe you are using your API key and maybe you have like thousands of users and the gas fees are very high. So at that point you might have to like top up with them. But there's no, other than that, there's no reason why any transaction should be rejected. And gas fees are quite cheap in Starknet. So you can use $1 to like interact with so many dApps on the Starknet ecosystem.
All right, thank you.
Yeah. Mm. So is there any other question?
Martins. Okay, someone they say you should speak to them about gospel.
About GhostPay?
Yes.
Oh, okay. So basically I'm building GhostPay. So you know how when transactions are done on Starknet or in any other blockchain for that matter, you can easily go to the block explorer like Voyager or StackScan to see how money moves in an organization or company. For example, if me or Tosin sends you money to your Starknet wallet address, you can easily just go to our wallet address on Voyager to see how much I am holding or Sarah is holding. And imagine a company that wants to implement payroll using crypto using crypto. If someone has the company's wallet address, they can easily see um, how much they are paying this staff and this staff and this staff. And that kind of information can be harmful. For example, let's say I'm a rival company now and I want to poach some staffs from this other company, but I need to offer them something that is higher than what they are currently receiving. So I can easily just find the company's contract address and see how much they are paying each of their staff, and I have an unfair advantage in negotiating. So I can easily poach their staff. Another example is if me and this company now we want to bargain on something, or maybe I want to buy something. We both want something. I can easily go to their contract and see how much money they have. If I say, these people don't even have money like that, I can easily outbid them in anything. I already have that insider information of how much they have, how much they are currently spending per month. And I can use that information to be able to do anything, to have an unfair advantage over them in so many scenarios. So that's what GhostPay does. So that's what GhostPay counters. So GhostPay counters the wallet watcher problem. So it's what it does is that it helps you to, let me display here. So with GhostPay, you can hide your balances. So you can encrypt a certain amount of stack that you have. So that encryption is done with ZK. That encryption is done with ZK. And with that encrypted balance, why is this not working? Okay. Anyway. Okay. So and with that encrypted balance, you can send out money. So you can send when you send that encrypted stack, it's called T stack, the other person receives stack. And if you check my wallet, you can't see how that money was being moved. So this is ideal for companies or even people that want to send funds. Let's say you hire somebody now. Another example is kidnapping or robbery. I come to your house, I do a job for you. You pay me, let's say $50. I can see your wallet. I see that this man has $1 million worth of stack. The next day I'll come with boys and I can raid you, kidnap you or something because I know that you have that money to pay. That's that's another issue that GhostPay solves. So in GhostPay, let me quickly connect my wallet. Yeah. Uh-huh. So in GhostPay now, currently now we have the organization view where okay. We have the organization view where you're able to create your company and register employees that you have. So at the end of the month, you can use these encrypted balances. You can use these encrypted balances. So it's called, so this is the vault. It's called a vault. So you unlock it. Network is quite bad. So this is the vaults. So you see these are the encrypted balances. So you can top this up by shielding or unshielding. So if you shield it, you move your stack to T stack, and that T stack you use it to basically your pay your employees or pay one time workers that work for you. So you can add your organization. So if you go to Shoket DAO here, so you have your employee roster here. So at the end of the month, you have their monthly salary and all. You can review and distribute. And you can use this across the multiple tokens on Starknet, BTC, USDC, USDT, and you can either pay with your public wallet or Ghost Vault. So that is how it works. Then for those one-time payments, you go to Instant Pay, you select the currency that you want to use. So we can use our Ghost Vault currencies and pay, and they have no way of seeing your balances and all. So that's how it works. So that's how GhostPay works in a nutshell. So we are currently building to like expand it and add more features that are going to be needed, such as compliance, to make it compliant with government authorities in case of tax filing and all that. So that's basically what GhostPay is all about. I don't know if there's any other question. Okay.
Okay. Any other question? We're going to be closing the call. So guys, the hackathon start next week. It's advisable for you to start hacking as soon as possible. So from next week, there's not going to be assignments. So we're giving you the time to work on your project. Yes. So this week will be the last week for assignments. From next week, we're also going to be having classes. Who is this? Can I fuck go pay and submit? Who are you?
All these people.
Please don't do that. Don't do that. If you check the Notion page, you will see the list of hackathon ideas. Let me share the Notion page again. So you can always check the Notion page for everything that you need. All the links, we update it every week. How do you get teammates? Network with people. Not, you guys should network together. You can either build your project. My network is bad. You can either build your projects individually or you build teams. I think that's all. Is there any question apart from the class? Any other question before we close the call? We have just 2 minutes left. Okay, in the absence of no questions, thank you very much, Oshike, for the session today, and thank you guys for joining the call today. As usual, we're going to continue next week. Next week is all about building with Dojo. If you're interested in building games for your projects, you should look forward to next week. You can also check out resources so that you can have questions to ask the tutor. So next week is for Dojo, week session 1 and session 2. Yes, so you build with Dojo engine. Yes. And we're going to be sending the link for assignment tomorrow, week 3. If you haven't submitted your assignment for week 1 and week 2, please do. We're going to be closing the form on Saturday. Then week 3 assignments will go up tomorrow. So thank you guys for joining and enjoy the rest of your weekend. See you next week. Please, if you have any questions at all, the Telegram channel is always open. If you even want to, you don't have Teams, you can drop a message on the Telegram channel and I'm sure somebody will respond so you guys can act together. Thank you very much, guys, for joining. See you next week. Good night. Good night, Ebuka. Good night,
Thank you guys
everybody.
for having me. Good night.
Yeah, bye.
Mm.